All right, day 2 brain dump. I'm going to go ahead and just spend 5 minutes on it. I will continue to explain every piece that I add, but 5 minutes. I told you 5, I'm going to spend 5. Okay? I might write slower than I think, heads up. All right. Gotta set my timer. Life is rough. Boop. Come on. Ooh. All right, 5 minutes. Slope-intercept form. Slope-intercept form is non-proportional. And it's non-proportional because of this additional b, and that additional b is going to be your y-intercept. Your y-intercept will be labeled 0, comma, whatever your b value is, positive or negative. M is your slope, also known as your rate of change. When I say non-proportional, I mean, example, it does not go through the origin. Whereas this one's non-proportional, direct variation is always going to be proportional. An example on a graph means it's clearly going to go through the origin. All right, where my k is my slope. In order to find k on a direct variation problem, I know that k is equal to y value over the x value. I keep it proportional. Slope of a line, I know I can find it on a graph by doing rise over run. My rise is the change in y value. My run is the change in x. I know that this turns into y2 minus y1 over x2 minus x1, but what it actually looks like on an ordered pair is the first value and then the y value, 1, x2, y2. Now, with this, I know there are 4 types of slope. I draw the sexiest man alive to figure that out. Positive, negative, undefined, 0. What I would also add is the very easy questions of linear, nonlinear. Linear means it's going to come into a straight line. So I would underline line. And then nonlinear, of course, it's not going to be a straight line. It's probably going to have some type of curve to it. Okay? All right. I'd also add the types of associations for scatter plots. So you've got positive, where it seems to be going up. Might have an outlier, but it seems to be going up. Negative, where it seems to be going down. And then none, where it just seems to be everywhere. Looks like chickenpox. Chickenpox, excuse me. Okay, cool. Circle, I have 2 pi r. I know that the r center radius. Pi d, I know the d goes all the way across. Okay? Boop. For a triangle, I use area of a triangle for big B when I have a triangular prism. And big B goes there. Rectangles, when I have a rectangular prism. And the big B either goes on top or down bottom. Trapezoids, I don't use those, but circles I do use when I have either a cylinder or a cone. That's my big B. Cool. All right. Triangles. I use triangles when I know that the inside is 180. Then I also have the exterior angle theorem that tells me the outside is equal to the 2 remote interior, the 2 inside. I also know that a rectangle, they like to use rectangles and squares to show Pythagorean theorem, because if I split it, I can get a hypotenuse. All right, prisms. I need you to know big B is area of the base. And big P or capital P means perimeter of the base. Lateral, you need to know it's sides only. And they do around or label as keywords. And then total is entire shape. And that's the time for 5 minutes.